From the southwest corner of the Spokane Valley, let's get ready to go to the Unit 4 practice test.
Yeah!
All right. So, as soon as my children, my class, my students settle down, we'll get started. Okay, so the first one asks us to solve a system by graphing. Okay, we're asked to draw an arrow indicating the solution on the graph and be sure to label our solution as an ordered pair. I know that if I'm going to graph a line, on the first equation, I need to solve for y first, or get y alone, so it's in slope-intercept form. So I'm going to add 5 to both sides and get y equals x plus 5. So the reason I do that is that makes it really simple for me. I'm going to start with a y-intercept of 5, rise 1, run 1, and that's going to give me that line. I'll go ahead and put the points for the second line, and then we'll fill in the lines themselves. This one is going to start at -1, and we're going to rise -5, run 1. So -5, +1, or +5, 1, 2, 3, 4, 1, 2, 3, 4, 5, -1. Okay, and I see the point of intersection already. Looks like it's going to be right there. But let's go ahead and fill in our lines just to show all this. So we have line number 1, something like that. We have line number 2, something like that. And just fix those as skosh. And remember, the point of intersection is the solution, if there is a point of intersection. So in this case, the solution is -1, 4. And if I plug and chug back into both equations, it would work. Number 2 and 3, you could have used any method, whether that be graphing, substitution, or elimination, but these work out well for substitution since you already have y alone in the second equation. So all I'm going to do is take what y equals in the second equation and plug it in for y, or substitute it in for y in the first equation and solve. So I have 3x plus 2 times -3x plus 11 is 7. I'm going to simplify by distributing. So be careful. This is where some of you are making mistakes with integers and messing up with your positives and negatives. Okay, I'm going to simplify. 3 plus -6 is -3. Then I'm going to subtract 22 from both sides and get x, -3x equals -15, so x is 5. So if x is 5, I plug in 5 back into one of the equations. I'll just go into this one, doesn't matter. That one will be easier. So then y is -3 times 5 plus 11, which is -15 plus 11, which is -4. So my answer is 5, -4. Okay, on the third one, again sets up for substitution, but you first need to solve for x on the first equation. So I'm going to go ahead and do that. I need to get x alone. I could do y, but I would be dealing with some fractions then. I don't want to do that if I don't have to. So I'm going to get -6 minus 2y here for x. And then I'm going to take what x equals in the first equation and substitute it into the second equation. So then I'm going to get 3 times -6 minus 2y. Be careful with your negatives there. I could see some mistakes happen there. I'm going to do plus and negative and take out any uncertainty with signs, because then I'm just multiplying positives times negatives. And then I'm going to simplify by combining like terms, and I get -20. Well, actually, I get -6 plus 8 is 2y. So -18 plus 2y equals -20. I'm going to add 18 to both sides and get 2y equals -2, so y is -1. Okay, if y is -1, then I plug that back in for y into one of the equations. Let's go into the first. So if I plug this in up here for y, I get x plus 2 times -1 equals -6. So I get x plus -2 equals -6. Add 2 to both sides, and x equals -4. So my solution is -4, -1. Okay, well, hopefully if you look at your work, you can compare it and realize what you did wrong. Okay, I once again would say number 4 works well for substitution. So I'm going to substitute this in for x in the second equation. So 2 times negative 4y plus 4 plus 8y equals 8. And something interesting happens when I distribute and combine like terms here, so watch closely. When I distribute, I get negative 8y plus 8y equals 8. And negative 8y plus 8y is 0, so I get 8 equals 8. And we know if we ever get 2 equivalent quantities and no variable left to solve for, it will be infinite solutions. You know, that's what we know. Alright, in the next problem, now all of a sudden we're getting to some that look like maybe elimination would be a better method. Is there a number I can multiply the top equation or bottom equation by to get my answer? No, so I have to do both, right? So I'm going to do both, and I heard a 10 and a 3. I like multiplying by 10. That's always really easy. And the reason I don't have to change the sign on 10 or 3 is one's already positive and negative, so they're going to cancel each other out when I add them. So on the top, I'm going to get 30x plus 90y equals 330. And on the bottom, I'm going to get negative 30x minus 18y equals negative 42. So now I can simply go, that's 0, so 72y equals 288. And what looks like a big number and might come out to be something funky really came out to be something nice and even, a nice 4 for y. Then I can plug in 4 for y up here and get x. So let's do that in a different color just to separate them out. 3x plus 9 times 4 equals 33. 3x plus 36 equals 33. Subtract 36 from both sides. So 3x equals negative 3, and x is negative 1. So I get an answer of negative 1, 4.
I sound way differently, but I still have the right answer.
Great. Lots of different ways to do each of these problems.
Automatic substitution.
Okay, number 6. Number 6, I can't substitute unless I want to put them in standard form. So in order to put this top one in standard form, I'm going to have to subtract 4y from both sides. So I get 3x minus 4y equals negative 18. On the bottom one, I need to subtract 5x from both sides. So I get negative 5x plus 16y equals 58. Once I get them in standard form, then I can see that I can just multiply the top equation by 4. And the 16 and the y's will cancel out. So when I do that, I get 12x minus 16y equals negative 72. So this became this, okay? So then I just can combine those, and I get 7x equals negative 14. X is negative 2. I will not slow down, but what I will do, because we need a lot of time in the rest period, is you will be able to go back and watch it at your own pace tonight. Okay? So x is negative 2. So then, when I plug negative 2 in for x, let's go into the first one. I have 3 times negative 2.
You dropped something, hey.
3 times negative 2 equals negative 18 plus 4y. I'm just plugging into the original equation. The reason I want to plug in the original and not one of these is if I made a mistake converting some of those, then it may appear to work and it doesn't. So then I can get negative 6 equals negative 18 plus 4y. I'm going to add 18 to both sides and get 12 equals 4y. Divide by 4 and you get y equals 3. So I get my answer of negative 2, 3.
It's right there.
Okay. Moving on. And again, we want to get through this so you have time to do some more practice today, and tonight you can go through and pause and go at your own pace. So that's the plan. Okay, number 7. 7 looks like a really easy one to get y alone. So I'm just going to add 5x to both sides. And we can see that when I do that, I get y equals 5x minus 6, or negative 6 plus 5x, either way. So then I can substitute this in for y in the second equation and solve. And again, you may have had a way that worked for you or made more sense for you, and that is A-OK. So I have 15x minus 18 minus 15x equals negative 12. I realize when I simplify that 15x minus 15x is 0, So I get negative 18 equals 12, and that is not true. They are not equal. There's no variable left to solve for. Therefore, it's no solution. All right. James, the soundtrack will be coming out soon. No solution. All right. Number 8. The length of a rectangle is 3 centimeters more than 3 times the width. So I'm going to go ahead and call, let's see, what did I do on my paper just to be consistent? I called the x equals the length of the rectangle, and length of the rectangle, and y equals the width of the rectangle. I need 2 equations. Let's do the easy one first. I don't know what grade, maybe 5th or 6th, you first learned that the perimeter is the distance around, and you can find the perimeter of a rectangle by just doubling the length, doubling the width, and adding those together to get your perimeter. So that's the easy equation in this situation. The second equation says the length of a rectangle is, so length x is equals 3 centimeters more than 3 times the width. So 3 times the width and then 3 more. So there's my 2 equations. Okay, now I can simply, well, I've already solved for x in the second one, so I'm going to use a little substitution again. So I'm going to substitute that in for x in the top equation. And I'm going to get, I'm going to go ahead and make a little work box here, because we're getting a little bit of a cluster. So that, okay. So then, when we substitute that in, we're going to have 2 times 3y plus 3 plus 2y equals 46. We need to do a little simplifying. So 6y plus 6 plus 2y equals 46. Simplify a little more. 6y and 2y is 8y plus 6 equals 46. Subtract 6 to get y alone, and 8y equals 40, and y is 5. Okay, 5. What's 5? It's the width. So the width is 5 centimeters. Okay, well, if I plug that in here, 3 times 5 plus 3 is 18. So that means the length is 18 centimeters. Okay, so I'm going to go ahead and write down that solution. 5 centimeters. I'm going to go ahead and write it out. So the length equals 18 centimeters, and the width equals 5. Okay, and I can check it. 18 plus 5 is halfway around the rectangle, right? And that's 23. All the way around will be twice that, or 46. And is the length 3 times the width plus 3? Yes, it is. So it works. It checks out. All right, moving on to number 9. Number 9. All right, so number 9. Now we're going to deal with the nickels and dimes problem. So let's first of all think about the easy equation, and first of all we have to define the variables, right? So we need to figure out how many of each coin he has. Oh, that must be how many nickels, okay? And y is the number of dimes. And how many coins do I have all together? I have 46 nickels and dimes, so if I add the nickels and dimes, I get 46. The second equation is where some of you were stumbling a bit, but if I am finding total value in dollars and cents, I need to figure out how many nickels and how many dimes, but I have to think about how much those nickels and dimes are worth. So I have to take my number of nickels and multiply it by how much a nickel is worth, and the number of dimes and multiply it by how much a dime is worth. So that's where some of you were getting tripped up a bit. The rest, though, is just same thing we've been working on all along, and that is to apply one of our strategies. I find substitution to work better here. Some of you may like elimination, and that's okay, as long as you get the right answer and can show it. So I would just solve for y in this top equation. I could solve for x just as easily, but it's going to go with that. So then I can plug in that for y in the second equation. And I'm going to have 0.05x plus 0.10 or 10 cents times 46 minus x equals 375. I need to do a little distribution. That's an x, by the way. So we get 0.05x plus, when I multiply by 46 by 0.1, it's going to move the decimal 1 to the left. So it's going to be 4.6 minus 0.10x. And then I'm going to go ahead and go 5 cents minus 10 cents is negative 5 cents. And that's $4.60. So just because we're talking about money, I'll go ahead and put the 0 on it. I'm going to subtract 460 from both sides to get x alone. And I get negative 85 cents. Home at negative 85 cents. Good job. All right. And then we go ahead and divide both sides by negative 5 cents. And I get 17. What does that mean? 17 nickels. If there's 17 nickels, how many dimes? 17 plus what is 46? Then the answer is 29. Okay. So just a minute. So so the answer is 17 nickels, 29 dimes. Again, I'm going to double check it. Is this 46 total coins? Yes. This is 85 cents and this is 290. I do that in my head, and in fact that does equal 375. So it all checks out. Question?
No.
Not anymore.
Great job.
Again, the reason I'm recording this is so you can go back and you know, at your own pace, stop, check your work, and so on. So the herbicide problem, okay? You may or may not know what that is, but something that farmers use. So what needs to happen here? This guy needs to buy some supplies, and he's going to mix them, or she's going to mix them, excuse me. So in order to apply this to a large field, she needs to mix a solution of 67% herbicide with 46%, and it needs to form 42 liters of 55% solution. The question is, how much of the 67% solution must you use? So again, we always start out with defining the variables. X equals the liters of 67% herbicide. The Y equals liters of 46% herbicide. And so that leads us to our easy equation. If I take the total liters of 67% and the total liters of 46%, I get a total of 42 liters. So that's the easy equation, the one we want to start with. So we get that one done. Now our second equation we need to think of, how much of this solution is actually herbicide, okay? So my number of liters of herbicide are going to be represented by X times 0.67. Because when I multiply 0.67 times X, I'm going to find 67% of that number, which is pure herbicide, okay? Then I'm going to add that to the one that is 46%, so I have to find a percent of the number I multiply, and I'm going to get a solution of 42 liters, but I want to see how much herbicide that is. So it's 42 times 0.55. That's going to give me how many total parts or percentage of the actual solution is herbicide.
So you get here from 542.
Yep. So you need to simplify the bottom equation before you do anything. Good. So when we multiply 42 times 0.55, what do we get? Thank you, Brandon. 23 point. I think it was more than that. Wasn't it? Okay. All right.
Yeah, thank you.
So what do you guys want to do? Elimination or substitution?
Lucky jug.
Okay, we'll keep going with substitution. That's what I would use anyways. Subtract x from both sides. So y equals 42 minus x. Now I can plug what y equals in the first equation in for y in the second equation and get 0.67x plus 0.46 times 42 minus x. And that equals 23.1. Now I need to do some distribution to simplify. I've been doing that a lot, especially if you're using substitution. 0.46 times 42, this is when your calculator comes in handy. So I'm going to go 0.46 times, what did I say? 42 is 19.32. So I get 19.32 minus 0.46x. Hopefully you didn't need a calculator for that one.
I was about doing it.
Okay. Now we go ahead and simplify by combining like terms. 0.67 minus 0.46 is 0.21 plus 19.32 equals 23.1. Now I need to get x alone, so I'm going to subtract 19.32 from both sides. And again, this is where a calculator is going to come in handy.
3.78.
Are you sure?
Yes.
Eric says he's sure that it's 3.78, so we'll avoid the calculator because he used one.
Yes.
So then we divide both sides by 0.21, and we get
18.
18, Eric says. 18. Okay, so
Good job, Eric.
x equals 18. So what is x and what does that mean? Okay, x is the liters of 67% herbicide. So that means 18 liters of 67% herbicide. Is that what we're asked to find on this problem? Okay? Yes, that is what we're asked to find on this problem. So we're done. Okay, we could find y, but we really don't need to. Although I would want to find y just to make sure I did this right. So I'm going to go ahead and plug it back in and make sure. So if I get x is 18, the easy equation would be to plug it in this, right? So 18 plus y is 42. So obviously that's going to be 24. Okay, so y equals 24. And if I check it, it does work out. So there's the herbicide problem, just like the acid problem in your math toolkit. Okay, on number 11, the wind and current kind of problems, we know there's two basic equations. One is a plus w equals ground speed, and the other is a minus w equals ground speed. So the things we're missing here is one, we need to define our variables. So a equals airspeed and w equals wind speed. And the second thing is, do we have our ground speed?
Yeah, you just do 1,136 divided by 3.5.
Right, we do not have it. So if I take my miles and divide by my hours, it's going to give me how many my rate, or how many miles per hour I'm going. So in the first situation, I have a plane that's going 1176 divided by 3.5, which is how fast?
336. Yeah.
Thank you, 336 miles per hour. In the second scenario, I have a plane
392 miles per hour.
going 1176, so they're going the same distance in half hour less, so they're obviously going faster, which is how fast?
392.
Okay,
Yeah.
so then I go, and this is one mistake I saw students make. If you're going with the wind, are you going to be going faster or slower? Faster.
Oh, that's good. Sorry.
If you're going against the wind, you'll obviously be going slower. And so now, all the hard work's done. The elimination part's really simple here, because they will always eliminate each other. And I get 2a equals 728, and divide by 2, and I get a equals 364.
That was so easy. Yeah, that was really
Yeah, I never got these problems until now.
I thought they were going to be super
Okay.
subtractor 54.
So 364 is what they would be traveling per hour in a vacuum. So if they're going with the wind, it's going to be 364 plus what is 392, and we get what? W is 28, right?
Sure is.
Okay? So I need to put 364 back into one of the equations. Do you want me to show you that? Let me show you that.
Alright, you can show us.
Well, I just want to make someone say, what you talking about? So,
Are you serious?
2 years
What
old?
is it?
okay. So if I plug this back into the first equation, 364 plus W equals 392. Subtract 364 from both sides, and I get W equals 28. What does W stand for? The wind speed. So what are we asked to find? The wind speed. So wind equals 28 miles per hour. Please label your word problems and make sure you answer the question asked. Okay, now we have the bonus. Bonus is actually quite simple. In high school, and when you're in Algebra 2 trig, you will have problems where it's x, y, and z in all three equations. That gets a little dicier. But this one's kind of interesting because if you solve for x or y in the top one, because you have both x's and y's, then you can plug in x and y in the bottom one to get z. So most of you actually got the bonus right. So in this one, if I already am set up for substitution, so I'm going to substitute that in for x in the bottom equation. So then I get 5y equals 4 times y minus 5 minus 6. So I get 5y equals 4y minus 20 minus 6. And that's plus a negative, so I don't make a mistake with signs. So 5y equals 4y plus negative 26. So I get, when I subtract 4y from both sides, I get y equals negative 26. Okay? So y is negative 26. On the next one, I need to plug in that into one of the equations. So I'll just plug it into this guy right here because that's pretty simple. X equals y, negative 26 minus 5, plus the negative, that's 31. So x is negative 31. And then I just have to plug in those two values to z, to find z. Z equals negative 10 times negative 31. I'm going to move this down here out of the way. Okay, and then we're going to go ahead and take to that, and we're going to go minus 5, or plus a negative 5, so you don't make a mistake with that, times negative 26. And I'm going to get z is 310 plus 130, which is 440.
Do not erase.
As I said, you can go watch it at home. And finally, the last break-even problem, or like a break-even problem. Again, I don't know. So, we'll talk about it, okay? They very well may be, Brandon, without giving it away. Okay, so my variables in this problem. Now remember, if I'm doing a break-even problem, y is always going to be my cost or income. Kind of funky, but that's just how we do break-even problems because we need two lines representing, each one representing one, either cost or income. And in the long run, we need to see where they intersect to find that break-even point. So our variable in this problem is, what's going to vary?
Number of copies.
Okay, the number of packages of each disk. Okay, so x equals number of packages
I say copies are okay.
of disks. Oh yeah, it does say copies. Okay. We'll just go with what it says. Number of copies.
Yeah,
Number
you
of.
get it wrong.
Okay. So then I need my two equations. How much is it costing me to run this business, James? You should really be paying attention. It's costing me $3,255 plus. I'm only paying $290. I'm only paying $290 per copy. But I'm selling them, and I've done some market research, and I know I can sell them for $13.75, and people will buy them. So those are going to be my two equations. Now, the challenging part here is to figure out my intervals that are going to fit on this graph because there are none. But if you think about it, if both of these are set equal to y, then if I substitute, then I can just set these equal to each other. Because really, isn't that what I'm trying to find, is when they're equal to each other? Yeah. So it kind of makes sense. So if I go ahead and solve with substitution before I show the break-even point, I can go ahead and subtract 290x from both sides and get, that would be 1085x equals, so that really shows me I'm making 1085 per copy, right, that I sell, or every time I sell a copy, equals 3255. Now I can divide both sides by 1085, and what do I get? Somebody with a calculator tell me? I get 300. What does that mean? That means it takes 300 copies, and what amount of money is that going to equate to? When I plug in 300 to either equation, I'll just go into this one because that's really easy, and we use our calculator and we realize it's what? Okay, so y is $4,125. Okay, so what that means is if I buy 300 copies and pay my overhead costs, I have to pay $4,125. If I sell 300 copies, I'm going to make $4,125. So that's the point at which I break even. Okay? So now we need to illustrate that or show that on our graph. So we're going to just move this off to the side a bit. Okay? I know I need X is my independent variable always goes on the X-axis. So my number of copies goes here, and my money goes on my dollars go here. I need to go up to 300 copies, and I have how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if I go 300 divided by 14, what do I get? A little more than 20, right?
You get 21.4285714.
Okay, so I'm going to make each one 25. Sound good?
Yeah.
So I'm going to label every other one just to not get too crammed here with my spacing.
You're doing what?
I'm just labeling every other one. Every interval is 25, and I'm just labeling every other interval. Then on my y-axis, we're talking dollars. Let me zoom out a skosh so we can see everything here. So dollars then, I need to go up to 4,125. What's 4,125 divided by 14?
294.
Thanks. You're a step ahead of me. So I'm going to round that up to 300. So if everyone's 300, every other one is 600. Again, this isn't the only right way to do it. It's just how I would do it because I can fit everything in my graph and almost fill up the entire graph. So then I can simply go, where's my starting point for the first one? 3255, right? And where do I know, this is 300, so it's about there. Where do I know they're going to intersect? 300, 4125, right? 300, 4125, which this is 39, so it's going to be closer to 4200. So that looks pretty darn good. So I'm going to go ahead and use this, and I'm going to make it a array because it starts at this point, and then it's going to go on forever as long as I keep buying and selling. Okay? So I know that's my break-even point. That's another advantage of knowing my break-even point. I can graph the starting point and the break-even point, and I can get an idea where everything lands. Then I can do my other one, and I know it starts at 0, and it has the same break-even point. Okay? So again, I can just do that, and I go like this, and I'm going to fix that because I don't like the way that looks there, and put an arrow on the end of that.
Dangerous.
That was so.
Okay, so here's the cool thing about break-even point. We can see we were in the hole, meaning we still owed money, we had to borrow money or something, and we're in the hole up to that point. We were in negative balance. We had spent more than we made. At this point here, we finally broke even. Okay, that's our break-even point. But here's the best part of being in business and staying in business and having a successful business is when you stick with your business. Then, after you've paid off your debt, then all of a sudden you're pocketing a lot of profit. Okay, you're pocketing $10.85 per copy. So if you're selling 100 copies, that's $1,085. 1,000 copies, $10,850. And you get how that keeps moving as you sell 10 times more copies. Okay? So there you have it. That took a long time, but now you can go back at your own pace, watch through this. There'll be the test itself is set up just like this. Similar problems, similar difficulty, so you know exactly what to study tonight. Too many hours.
I don't think we have time for